Today we're going to talk about gas laws. There's a few different gas laws that we're going to talk about in this unit. Gas laws are simple mathematical relationships between volume, temperature, and pressure of gases. When we do these problems, we're always going to want a sig fig. So what we're going to do is we're going to set up a series of different problems to figure out, okay, if I have this volume, this temperature, what pressure would this gas be using these gas laws? So the first gas law we're going to look at is the combined gas law. This relates all three factors, temperature, pressure, and volume. Right here we have the combined gas law formula, which you don't have to memorize because it's on page 12 of the reference table on table T. What the formula reads is pressure 1, P1, times volume 1, V1, divided by temperature 1, T1, is equal to the second pressure times the second volume divided by the second temperature. So we say P1 times V1 divided by T1 is equal to P2 times V2 divided by T2. This T2 really should be over here. Whenever you're working with these gas laws, you're always going to want to put your temperature into Kelvin. If you don't put your temperature into Kelvin, it is not going to work. Temperature is right on the first page of the reference table if you forget how to convert to Kelvin. Okay. So let's do some practice problems. A helium-filled balloon has a volume of 50 liters at 25 degrees Celsius and 1.08 atm. What volume will it have at 0.855 atm and 10 degrees Celsius? So when approaching these problems, what I like to do is put a letter next to a number. This is going to help me figure out, okay, which mathematical formula do I need to use? So 50 liters, that's a volume. 50 liters is a volume. 25 degrees Celsius is a temperature. 1.08 atm is a pressure. What volume? Volume is going to be my question mark. 0.855 atm is a pressure, and 10 degrees Celsius is a temperature. Then I like to make a little chart on the side to help me organize my values. So a helium-filled balloon has a volume of 50 liters. That's going to be my V1. The T1 is 25 degrees Celsius, but I have to turn that into Kelvin, so I do that by adding 273, and I get 298 Kelvin. My P1 is 1.08 atm. Now my V1 is my question mark. My P2 is 0.855 atm. And my T2, I have to change that into Kelvin, so I get 283 Kelvin. Now I'm going to write down the formula that I'm going to use. So for the combined gas law, we have P1 times V1 divided by T1 is equal to P2 times V2 divided by T2. It's the pressure, volume, and temperature of the first set of conditions. And then if we change to the set of conditions, we can find out what the third variable would be. So I'm going to go back to that blue color just because it's easier to see. And then we just plug in. P1 is 1.08 atm, 50 liters for our V1, divided by 298 Kelvin is equal to 0.85 atm. The V2 is our question mark, so that's the variable we're looking for, divided by 283 Kelvin. So I'm going to solve for the number on the left, 1.08 times 50 divided by 298 Kelvin. I get 0.181. I'll go 3 sig figs. Is equal to, now I'll do 0.855 divided by 283. And I'll get 0.00302 times V2. That's still what I'm looking for. I'll divide by 0.00302. These cancel. My V2, if I do 3 significant figures, because that's the smallest one I started with, I get 59.9 liters. Okay? So what this problem is saying is that if you start under these conditions, 50 liters, 298 Kelvin, and a pressure of 1.08 atmospheres, and I change my pressure to 0.855 atmospheres, and I change the temperature to 283 Kelvin, my volume will now be 59.9 liters. Okay, let's take a look at this next problem. A 70 milliliter gas sample at STP is compressed to a volume of 200 milliliters, and the temperature is increased to 30 degrees Celsius. What is the new pressure of gas in kilopascals? So before we were working with ATM, which is another unit of measurement for pressure, but now we're going to look for kilopascals. So I'm going to put letters next to numbers. 70 milliliters is a volume. 20 milliliters is a new volume. 30 degrees Celsius is a temperature. What is the new pressure of a gas? Well, we're working with the combined gas law, which is P1 V1 divided by T1 is equal to P2 V2 divided by T2. But I only have 2 volumes and a temperature. Whenever you have this, do not panic, because you're told that it is at STP. So since we are told that it's at STP, we can figure out what the pressure and the temperature is. If you go to your reference table and you look on the first page right here at table A, it says that standard pressure is 101.3 kPa or 1 atmosphere. So we're going to use this value right here as our pressure because we're at STP, we're at standard temperature and pressure, and I'm going to use the kPa one because our question wants our answer in kPa. And then I'm going to use this value for standard temperature because we always have to use Kelvin when solving these problems. So I'm going to say that, okay, our P is 101.3 kPa, and our T is 273 Kelvin. So now I'm going to create my chart on the side. My V1 is 700 milliliters. It doesn't matter if you're working in milliliters or liters, just make sure your volume units are matching. My P1 is 101.3 kPa. My T1 is 273 Kelvin. My V2 is right here. It's at 200 milliliters. It says that our temperature is increased to 30 degrees Celsius. So I'm going to change that 30 degrees Celsius into Kelvin. So our T2 is 303 Kelvin. So it went from 273 to 303. And it wants to know what our P2 is, so that's our question mark. So now I'm going to plug these values in. Our P1 is 101.3 kPa times our V1, which is 700 milliliters, divided by 273 Kelvin. which is equal to our P2, which is our question mark. P2 is like our X. Our V2 is 200 milliliters. And our T2 is 303 Kelvin. So I'm going to solve 101.3 times 700 divided by 273 is 259.7 is equal to 200 divided by 303, which is P2 times 0.6601. Doesn't matter about sig figging here because we're just going to sig fig our final answer. So then we do 0.6601, 0.6601, so we isolate the P2 by itself. So 259.7 divided by 0.6601. And we are going to get that this will cancel. We'll get our P2 is equal to 393. And we're going to sig fig that to 3 places. KPA. That's our final answer. That's what our P2 would be. Okay, let's look at the next problem. I have an unknown volume of gas at a pressure of 0.50 atm and a temperature of 325 Kelvin. If I raise the pressure to 456 kPa, decrease the temperature to 320 Kelvin, and the measure of the final volume to be 48 liters, what was the initial volume? So here I have an unknown volume of my gas, so I'm looking for a V. The pressure is 0.5. The temperature is 325 Kelvin. If I raise the pressure to 456 kPa, so this is the pressure, but it's also our second pressure, and I decrease the temperature to 320 Kelvin, well, that's the temperature, but it's also our second temperature. And the final volume, so this is going to be our V2. What was the initial volume? So our V1 here is our question mark. So now that I've helped you identify which letters go with which numbers, why don't you pause the video, try the problem on yourself, and then when you're done, unpause it and come and check your work. Okay, so I hope you had some luck with your work. Let's check. See how you did. So my V1 is my question mark. My P1 is 0.5 atm. My T1 is 325 Kelvin. My V2 is 48 liters. My P2 is 456 kPa. And my T2 is 320 Kelvin. So I hope that you noticed that your pressures were in different units. If you didn't know that, your answer is going to be incorrect. So what you have to do is you have to convert one of your pressures so your units match. It doesn't matter which one you convert to, your answer is going to be the same. I'm going to convert my kPa so that it's in atmospheres. So I've got 456 Kelvin, 456 kPa. I want kPa to go on the bottom so it cancels out, and I want atm on the top. For every 1 atm, that's 101.3 Kelvin. So 456 divided by 101.3, and that gives me 4.50 atm. So I'm going to change my P2 value to match that. You could have done the opposite. You could have converted ATM into KPA. Both work perfectly fine. Okay, so now I'm going to plug it to the formula. I'm going to write a little small because I didn't leave myself a lot of space. I'm going to be using the combined gas law. So my P1 is 0.50 ATM. My V1 is my question mark. My T1 was 325 Kelvin. My P2 was 4.50 ATM. My V2 was 48 liters. And my T2 is 320 Kelvin. So I'm going to solve for the numbers on the right. So 4.5 times 48 divided by 320. So this is 0.675. On this side, 0.5 divided by 325 gives me 0.001538. Again, it doesn't matter how many numbers you write down. Times V1. To get V1 by itself. So this cancels. V1 is equal to so my calculator reads 438.88. And if I was going to sig fig this, I would have to sig fig it to 2. Because of my 48 and 0.5, that's only 2 sig figs. So my answer would be 440 liters. Okay, so if we take a look at this next problem, it says I have an unknown volume of gas at STP. If by increasing the temperature to 225 Kelvin and decreasing the pressure to 98 kPa causes the volume of the gas to be 29 liters, how many liters of gas did I start with? So let's see. STP. STP, standard temperature and pressure. So if you looked at your reference table, you would have to pick kPa for your standard pressure to make your life a lot easier because you already have kPa in the problem. So your P1 would be 101.3 kPa, and your T1 would be 273 Kelvin. Please pause the video and try this problem on your own. When you're done, come back for the solution. Okay, so I'm using the combined gas law, so I'm using P1, V1 divided by T1 is equal to P2, V2 divided by T2. So if I create my chart on the side, my P1 is 101.3 kPa. My T1 is 273 Kelvin. And then my V1, well, the question says how many liters of gas did I start with, so that's my question mark. I don't know that one yet. My P1 was 98 kPa. My T2 is 225 Kelvin. And my V2 is 29 liters. So now I'm going to punch this into the formula. Got 101.3 kPa times V1, that's my unknown, divided by 273 Kelvin is equal to 98 kPa times 29 liters divided by 225 Kelvin. If I solve for the right side, 98 times 29 divided by 225. I get 12.63. On the left, 101.3 divided by 273 gives me 0.3710 times V2. Divide both sides by 0.3710. This cancels. V2 is equal to 12.63 divided by 0.3710. You get 34 liters. That's 2 sig figs.